proofs, you get a little overwhelmed at first. You look at it and you see, given all of this information, there's a bunch of symbols in there, you kind of freak out, and you cannot immediately see the connection between the parallel lines and the congruent triangles. And not being able to immediately see the connection is enough to make you think that you don't know what you're doing, okay? Because a lot of you, especially those of you where math is one of your strengths, are used to looking at a problem and knowing the answer, okay? And that's not the case with proofs. With proofs, you can't help but show your work, okay? So my first step is always to do what? Get the given. Nobody is ever going to get that one wrong, right? I hope.
I might.
So UQ is parallel to VR, and UP is equal to RP. And that is given. I did at least see those of you who were scared to try the 2 on the back, you had at least written given in for the first step. So kudos on that. Way to go. And then what I would do, as soon as you have that given, I would mark what it tells you. So what does this symbol mean? Parallel. So this is saying that UQ is parallel to VR. Now, as soon as I see parallel lines, look at your little proof toolkit up there on the board. Okay, well, it might be covered up, but you should have it too. Parallel lines. Look at your different options there. What's jumping out at you that would have to do with parallel lines? Yep, Franklin? Okay, no, I mean like your different reasonings, like the ways that you can show that angles and sides are congruent. Which one of those jumps out at you when I'm talking about parallel lines? Matt, you think you know?
Is it, since it's kind of looks like QPB is like the, forget what it's called.
Transversal.
Yeah, transversal.
Mm-hmm.
Of UQ and VR, so you can kind of turn it into one of those.
You are right. And if I'm turning it into one of those, which of these things do you think is going to help me? Parallel lines and a transversal? Is there anything up here that... Nope. Which of these things up here have to do with parallel lines and a transversal? That is about isosceles triangles. Preston?
AIA.
There you go. AIA, AEA, and corresponding angles. Don't those come from parallel lines? Right? So that's sort of what I do is I think to myself, okay, how on earth would parallel lines help me to get some congruence somewhere? Well, I know when I have parallel lines, I have all those angle pairs that are congruent. So let's see if we can work with that. So, oh, question, go ahead.
That was in the angle section.
You're right. I just said something anywhere up there. Sides or angles. I just want to know what could I get to be congruent. And actually, it's given to you here that we're going to be using AIA. And Matt is exactly right. I'm going to take these lines and extend them just so you can see them a little better. And then I'm going to take QPV and make it a transversal. Okay, so look at just the red lines that are extended. Kind of ignore this line in the middle. What angles would you know are congruent by AIA? Caleb?
UQP and PVR.
Okay, so this angle and this angle. And I like the way you name those, UQP and PVR. Would it be okay in this case to just name them angles Q and V? Yeah. Okay, just to save myself some room, that's how I'm going to name them, but Caleb, you named them perfectly. So we know angle Q is congruent to angle V. Okay. And actually, we could have done this as a transversal too, but we're good with this one.
I was going to say that.
Yeah, and it wouldn't be wrong if you had pointed out like that angle U and angle R would also be congruent. It's probably just more than you need. Okay. And then my next step has to do with vertical angles. What angles do I have that are vertical angles? Laura? That's right, UPQ. UPQ would be this one. And RVP Oh, nope, sorry. RPV would be this one. Those are congruent because they're vertical. So I've got that angle, that angle. Oh, and I missed marking something from my given. Bad idea. Okay? I know that UP, this side, is congruent to RP, this side. Okay, so now look at the triangles you've got in that picture. How do you know the two triangles are congruent? And remember, when I'm talking, anytime you've got a step that looks like this, you're going to be using one of those triangle congruence properties up there. Hunter?
ASA.
Almost. Matt?
AAS.
AAS. The side is not between the two angles. So that would be angle, angle, side. Okay? So again, you're looking for what pieces can you get to be equal. Making sense? I hope? Okay. Let's do our next one. All right. How many of you, be honest, how many of you looked at this and saw a circle and your brain went, whoop, I'm out? Okay.
I tried.
Okay.
Wasn't very good though. That sound like the Three Stooges.
Okay. What am I given here?
That
Matt?
circle.
That the circle is in C.
Okay, so I have a circle called C. That's my given. Okay. My next step, and they gave this to you, but I want to ask you, without that even being written, why is it helpful to have a circle? Rachel?
Because you know that the vertex, like every line coming out to it is congruent.
Okay, so from this, all of these segments, what are those little segments called? Yeah, they're all radii. Radii is plural, but yeah, they're each a radius, okay? Which, what I just marked there is exactly what this says. CX, CS, CY, and CT are all congruent to each other. That's what that says. So look at your toolkit up there.
Yeah.
Okay? Why do I know that those are all equal? Matt, go ahead.
Is it the definition of the midpoint? Because the midpoint is the center of the circle.
Good thinking, except that's not actually a midpoint. I mean, it technically is a midpoint of this, but simpler than that. Rachel,
Definition of circle.
definition of circle. Yeah, I know it's a circle, so by definition of a circle, I know all those pieces are congruent.
We just put like a circle.
Oh, you should say definition of circle. But you mean instead of writing the word circle? Yeah, that'd be fine. Okay, let's look at the next step they give us. Well, even if they didn't give us the next step, because I do, guys. Thank you. Even if they didn't give us that next step, what else do you see in this picture that would help us get something to be congruent? What else do you see? Something that would be congruent. Franklin, what do you think?
Angle YCT and angle XCS.
Okay, yes. Okay, Franklin is seeing these angles as being congruent. However, those angles aren't inside my triangles, right? So let's just switch that a little bit. You're not wrong, okay? Those angles are congruent to each other because they're... What are those called? Hunter, help him. What are those called? Those are vertical angles. I'm just going to switch it and do these angles so they're inside the triangle. Okay? And that's actually what you see here. XCY is this one, and FCT is this one. And those are congruent because why? Those are vertical angles. Yeah, vertical angle theorem. So now look at the picture. Do you have enough information to say that the triangles are congruent yet? Which theorem? Bryce, go ahead.
SAS.
SAS, yeah, side angle side. Now, with this one though, I wasn't trying to prove that the triangles were congruent. I needed to, but that wasn't like my end goal. My end goal was to prove that this piece here is congruent to this piece here. Well, how does having the triangles be congruent help me do that? Hunter?
Never mind.
Okay. how do I go from having congruent triangles to saying, now I know these pieces are equal? What gets me from congruent figures to congruent pieces? Matt?
Once you know the triangles are congruent, you know all the parts in both the triangles are equal to each other.
That's right. Do you remember what that's called?
Corresponding parts
Congruent.
congruent.
Yeah, CPCF, corresponding parts of congruent figures. Okay? Says that once I get the shapes to be congruent, all of their little pieces have to be equal too. Okay? So anytime you're asked to prove something like this, you're going to start by showing that two triangles are congruent and then say, hey, look, those are pieces of those triangles. Okay. And this one. This was the one that may have been a little iffy just because we didn't talk about regular, even though I told you right here what regular meant. But, what am I given? I'm given regular pentagon. A, B, C, D, E. Should have abbreviated that more. Given. Okay, so I want you to look at everything that's in step 1 there. Okay? In step 1, they are saying we know angle B is equal to angle E. We know AB is equal to AE. And BC is equal to ED. How do I know all of that? That's a ton of stuff. Jake?
CD thing.
Nope, the CPCF only works like if I already knew that those triangles were congruent. Okay?
Oh.
That's what I'm trying to prove. How do I know? Laura, has that a hand up? Right. That's what we told you right here. This step is always going to follow from this step. It's always going to have something to do with what was up here in your given. Okay? So in your given, I told you that this was regular. And then the thing we wrote down earlier is that a regular figure is when all the sides are equal and all the angles are equal. So really all 5 of these sides are equal to each other. And all of these angles would be equal to each other. Okay? So we know that because that's what it means to be regular. Okay. Uh-huh. Yep. How do I know then that my triangles are congruent? Go ahead, Caleb.
SAS.
You're right, SAS. So again, and I cannot emphasize this enough, most of them look pretty good as I was walking around today, but anytime you're saying that two triangles are congruent, your reasoning is one of those congruence theorems, SAS, SSS. That's why we learned all those. So now, how do I know that angle BAC, which is this little guy, would have to be congruent to angle EAD, which is this little guy? How do I know those two little pieces would have to be equal? Brooklyn.
CPCF.
You got it, CPCF. So are you starting to see some patterns in these, I hope? No? Am I seeing anything else?
Definition of regular. I don't understand.
Yeah, that's.
Okay.
She just told us.
Okay, so up there on the board, and actually it's written for you right here, the word regular, when I say it's a regular pentagon, a regular hexagon, that means that all of its sides are equal to each other. So like an equilateral triangle is a regular polygon because all of its sides are equal and all of its angles are equal. Okay? So when I told you that this was a regular pentagon, when I put that in the given, that was like a gold mine for you. Okay, as far as things that are congruent. Because knowing that it's regular means that all of these little sides are congruent. And knowing that it's regular also means that these angles, these interior angles are all congruent. Okay? So when I say definition of regular, that's because up here I told you it was regular. And so then my next step is to say, okay, what does that mean? How does that help me for it to be regular? Okay, what can I get out of that? Does that help a little bit?
Yeah, I'm
I hope. Okay. Okay. So let's try this.